Imagine a place so dense, it warps spacetime into an inescapable pit, a black hole. Born from the collapse of massive stars, black holes crush matter into a singularity, a point with gravity so intense that not even light can escape. The event horizon marks the point of no return. Cross it, and escape is impossible. For decades, physicists believed black holes were eternal prisons, erasing all information that entered. This idea clashed with a fundamental law: information in the universe can't be destroyed. If you burn a book, the information is scattered but not lost. In a black hole, it seemed to vanish forever. Black holes reduced everything to just mass, spin, and charge. A cosmic dead end. This contradiction exposed a rift between gravity and quantum mechanics, hinting our understanding was incomplete. Black holes were seen as the universe's monsters, permanent, silent, and unchanging. But the universe is full of surprises. A revolution in our thinking was about to begin, revealing a crack in the unbreakable prison. The story of black holes was far from over. In the 1970s, Stephen Hawking challenged the idea of black holes as eternal prisons. He combined Einstein's relativity and quantum mechanics, asking what really happens at a black hole's edge. Hawking discovered black holes aren't perfectly black. They emit a faint glow, now called Hawking radiation. This meant black holes could slowly leak energy and lose mass, evaporating over time. The cosmic prison had a secret escape route. Hawking's insight was revolutionary. Black holes have a temperature, and anything with temperature radiates energy. Over eons, black holes shrink, returning their mass and energy to the universe. This offered a possible solution to the information paradox. Maybe information escapes, encoded in the radiation. The details remain debated, but Hawking opened the door to a new understanding. Black holes weren't just endings. They had a long, dramatic story. The key to this cosmic jailbreak lay in the strange nature of empty space itself. To see how black holes leak, we must zoom into the quantum realm. At this scale, empty space is a bubbling quantum foam, where particles and antiparticles constantly pop in and out of existence. These virtual particles borrow energy from the vacuum, exist for a fleeting moment, then annihilate each other, restoring the balance. This dance is everywhere, all the time, invisible but fundamental. Normally, these pairs vanish instantly, unnoticed. But what if this process happens at the edge of a black hole? Hawking asked. What if a pair appears right at the event horizon? In most of space, they annihilate, but at a black hole's edge, gravity can split them apart. One falls in, the other escapes, a process that changes everything. The black hole's gravity turns quantum whispers into real, escaping particles. At the event horizon, a virtual particle pair appears, one inside, one outside. The one inside is lost forever, but the one outside escapes as real radiation. To the universe, it looks like the black hole emitted a particle, Hawking radiation. The energy for this escape comes from the black hole itself. The black hole swallows a negative energy particle, losing a tiny bit of mass. This process is slow and subtle, but relentless. Over time, the black hole shrinks, leaking energy, particle by particle. The unbreakable prison is now a leaky vessel. The flow is faint, but unstoppable. Black holes, once thought eternal, are now doomed to evaporate. The universe keeps perfect books. Every escape comes at a cost. The great escape has begun. Black hole evaporation is the slowest process in the cosmos. The bigger the black hole, the slower it radiates. Supermassive black holes will outlive everything we see today. A solar mass black hole takes 10⁻⁶ years to evaporate, trillions of times longer than the universe's current age. As it loses mass, the black hole heats up, radiating faster. In its final phase, it shrinks rapidly, glowing white-hot. The process accelerates, spiraling into a runaway feedback loop. The long, quiet goodbye becomes a frantic finale. All the mass consumed over eons is unleashed as pure energy. The stage is set for the black hole's final spectacular act. Even the universe's most permanent objects must eventually say goodbye. In its last second, the black hole is smaller than an atom, hotter than the early universe. All its mass energy erupts in a final, brilliant explosion of gamma rays and particles. The singularity and event horizon vanish, leaving only an expanding cloud of energy. Information, once thought lost, is returned, scrambled in the final burst. The prison is gone, the cycle is complete. Hawking's discovery reminds us, nothing lasts forever. Not even black holes. The universe recycles everything, even its darkest secrets. We've never seen a black hole die yet. Will we ever witness the final flash? The cosmos keeps us guessing.